Ernest Rutherford was born in New Zealand and was a British physicist. He also won the Nobel Prize in his work. The year was around 1909, 1910, so this is about the same time that Robert Millikan was doing his work on the mass and charge of the electron. So Ernest Rutherford built a very interesting contraption. What he did was he had a radioactive source. We're going to learn later that radioactive elements emit particles, and one of those particles is called an alpha particle. And so he isolated those alpha particles, and what he did was he watched them, he essentially aimed them at this little piece of gold foil. Now, when we think of gold foil, we might be tempted to think about aluminum foil, which is really nice and thick. This gold foil is very, very thin. It's between 4 and 6 atoms thick. Very, very thin. So because it was so thin, he was able to see how the alpha particles interacted with a very small number of atoms. As he shot the alpha particles at this foil, he expected them all to go through. Let's think about why he would expect them all to go flying through this gold foil. It's because at the time, the current model of the atom was the plum pudding model, which is made out of goo. Negative electrons floating in a positive goo. Think about organelles floating in cytoplasm of the cell. So he expected that these alpha particles would just rip right through the goo and go straight through. He had a phosphorescent screen, and this phosphorescent screen, when he is kind of like a film, it would allow him to be able to see when these radioactive particles interacted with it. And he did see the majority of the particles go straight through the foil. But occasionally, he saw a particle, alpha particle, get deflected to the sides or bounce back, which was totally unpredictable. He had no idea that that would happen. He was very shocked, and he had to come up with an explanation of why that happened. So if we look at this view, this is showing the atoms. There are very few atoms in his gold foil. It's only 3 atoms thick. Notice how these alpha particles are going straight through the gold foil. Here, they're going straight through the gold foil. But occasionally, one of the alpha particles is going to collide with something very dense and massive in the center of the atom. We didn't know it at the time, but that was the nucleus. So as that alpha particle interacts with that nucleus, it is going to go and be deflected to the side, which means it's going to go at an angle. Here, notice there's an alpha particle, and as it hits the nucleus, it's going to bounce back because of the angle that it hit that nuclei. So that helped Rutherford to conclude that there's something very dense and very small in the center of the atom. So just in summary, Rutherford expected the alpha particles to go straight through the foil. Instead, some of them bounced back, a very, very small percentage, but it was nonetheless shocking and surprising to the scientific community because he discovered a nucleus. There is something dense, something small yet massive in the center of the atom. Why did the majority of the particles go straight through? Well, that's actually also very important. That's because the atom is made of mostly empty space. So as we look back here, notice that yes, there is a mass, or the nucleus in the center of the atom that's quite massive, yet very small. But what about the rest of the nucleus? The rest of the nucleus is just empty. It's the electron cloud. The electron has a mass that is super small, as Millikan discovered, times 10 to the negative 28th. So it's very important to note that the atom is mostly empty space. That's also is just as significant as discovering the nucleus in the center of the atom. So now we need a new model of the atom. The new model of the atom was hypothesized by Niels Bohr in 1913. So this is just after everybody has made their discoveries about the electron, about the nucleus. So now we need a new model of the atom. He came up with what is called the Bohr model of the atom. In his honor, you've probably seen this before as the planetary model. So here we have the nucleus in the center based on Rutherford's experiments, and we have the electrons. He put them in very distinctive, specific orbits around the nucleus. So that's why it's called the planetary model. It's as if the nucleus was the sun, and then there's the planets like Mercury and Venus and Earth. They're all in very specific prescribed orbits around the nucleus. And that's pretty much where your previous science classes have left off. We're going to take that to another level and talk today about the quantum mechanical model. This is the model of the atom that is accepted today. The quantum mechanical model is different in that, yes, we still have the nucleus, but the difference is that we also have the electron cloud. The electron cloud is representing an area of probability of the electron. And we're going to find out in our next unit why we're not able to have the nice little orbiting planetary paths that Niels Bohr put the electrons in. But we have more of a cloud, this area that's a little bit vague about where the electron is. And we'll talk about that in our next unit.